All right, hey guys, we are going to go ahead and start Unit 12. It is all about exponential functions, okay? So we're going to pretty much just graph these and then answer some questions. So it's just like quadratics when we talked about attributes of quadratics. So like the axis of symmetry, the vertex, x and y intercepts, so on and so forth. So now we're going to talk about the things that you can find on an exponential function. Okay, so what I want you to do is in your calculator, you're going to graph this line. So 2 to the power of x. So on your calculator, I don't have a way to show you, but it's the 2, and then you're going, once you go to the graph part on your calculator, it's a 2, and then raise it to the power. It's that little arrow that goes up, okay? So it should be close to the number 4. It's going to be but on one of the buttons to the left on the number 4, and then you're going to press the x value, and it should make it a little x up top. So that's how we can tell it's an exponential, by the way, if x is an exponent, hence why it's called an exponential. Okay, all right, so if that's how we remember it, that's how I remember it. Okay, so we're going to graph this, and then I want you to fill in this table. So once you get your graph, you're going to fill in the table, and remember how we get our table is Control T. So when we press Control T and we fill in this table of ours, -2 has a y value of -2.5. -1 has a 0.5. 0 has a 1. 1 has a 2. And 2 has a 4. Okay, and then I want you to graph these. Okay, so we have 0, 1, 1, 2. Okay, and then 2, 4. -2 or -1.5. And then -2.25, so something like this. Okay, so then we have this graph, this beautiful graph. Oh god. So it should look like this when you graph it. Got it. Okay, all right, so now you're going to see the word asymptote. Okay, so asymptote is just a word that means it gets close to but never touches. So I'm going to write it right here. So an asymptote it gets close but never touches. Like never. Okay, so in this case, as I'm looking at it, okay, this will continue growing and will continue going to up and to the right. But our asymptote here is this line right here where it starts to flatten out. So in this case, our asymptote is the x-axis. Okay, and so remember the equation for the x-axis is y equals 0. Hint, hint to you, our asymptote will most likely always be, like 99% sure, will always be y equals 0. It will always be. All right, domain, okay? Domain, remember, domain is left to right. Okay, so we have an arrow going to the left forever. We have an arrow going to the right forever, up and to the right forever. So therefore, our domain is all real numbers. Our range, okay, all right, it's going to be the same as our asymptote, pretty much. So y, and it's going to be 0, but, okay, as long as our graph is above the x-axis, then our y is going to be greater than, just greater than though. Why? Because we have an asymptote. The asymptote tells me it never touches the 0, never touches the x-axis. So it's not going to be equal to. All right. So what happens to the function of y values as the values of x increase? So pretty much it's asking, as I go and increase the on the x-axis, what's happening to my y values? Oh, well, they're pointing up forever, right? So as I go to the right on the x-axis, it goes up forever. So that's going to be increases. All right. So that's what an increasing exponential function will look like. So number 2, we're going to do the same thing. Okay, I want you to clear your graph and graph this one. Again, how you get the little exponent, you're going to press the little caret top, okay, in your graph. It should be next to the number 4. All right, so once you graph it, we're going to press Control T to get our table. So -2 has a 4 value, -1 has a 2 value, 0 has a 1, 1 has a 0.5, and 2 has a 0.25. All right, and then I want you to graph it. So -2, remember, we'll go to the left 2 and then up 4. -1, 2, 0, 1, 1.5, my little guesstimate, and 2.25. So and then it flattens out. Forgive me for my graph. Okay. But again, our asymptote, where does it get close to but will never ever touch? Okay. So this is going to continue going up and to the left, but okay, my graph eventually will flatten out even or parallel with the x-axis. So again, our asymptote is the x-axis, which has a equation of y equals 0. All right. And again, for our domain, okay, remember it's left to right. So I go to the furthest left point and it's an arrow. I go to the furthest right point and it's an arrow. So it's going to go to the left forever and ever. It's going to go to the right forever and ever. So if that's the case, then it's all real numbers. We're going to hit every number on the x-axis. My range, okay, again, it depends on the asymptote, okay? So because the graph is above our asymptote, okay, which is y equals 0, we're going to use y and 0, and because it's above it, y should be greater, but it's not equal to, because we will never ever touch 0 because it's an asymptote. So now the question is, what happens to the function y values of the function of y value? So what happens to the y as the value of x increases? So as the value of x increases, so as I go to the right, okay, for my graph, what is happening to my y values? Well, we're going down. So as I'm reading this left to right, I'm going down a roller coaster. Okay, so if that's the case, then I'm decreasing. All right, so here is your rule of thumb. Okay, so in exponential functions, B stands for your rate. B is your rate. So pretty much how fast the graph is moving up or how fast it's moving down. Okay, all right, so if B is in between 0 and 1, so pretty much it's a fraction less than 1, but greater than 0, okay, it is going to be decreasing from left to right. So this means like 1 over 3, 2 over 3, 5 over 8, 12 over 13. All of those fractions are less than 1, but greater than 0, okay? If B is greater than 1, it's going to be increasing as it is going from left to right. Okay, so this is, if B is in between 0 and 1, it's going to be going down a roller coaster. If B is greater than 1, I'm going to go up a roller coaster. Okay, so think of it as your heart rate. Okay, your heart rate's going to increase as you're anticipating going up a roller coaster. So these are numbers as simple as like 10, 2, 5 over 2, even 4 over 3. All these numbers are greater than 1. Okay. All right. I want you to complete the back of this and then check it with the spreadsheet notes to the answers to make sure you are doing it correctly. All right. Bye, guys.